Okay. Algebra 2, trig functions. Yes, back in those days of geometry when you learned Chief Sokotoa of the Kapaktak tribe and all of our trig functions. Yeah, they're going to come back into play here. You'll need them in the pre-calc stuff as well. So let's recall. We'll get a couple new ones, and we will also get some of our old-time favorites in here as we work through this. So I'm going to use this triangle as my reference right now. But the reference angle, oops, can't see that, can you? There you go. The reference angle is going to be called theta. And that's the angle which, pardon the pun here, we're referring to. That's the angle we want to work with. So, by definition, sine, S-I-N-E, abbreviated S-I-N, is in a right triangle. Its opposite leg over hypotenuse. Cosine will be defined as adjacent leg adjacent to what? Your reference angle over hypotenuse. And tangent will be your opposite leg over adjacent leg. Now what you'll hear me do as we move through here with this stuff is I'll stop saying opposite leg and adjacent leg. I'll just say opposite over adjacent, opposite over hypotenuse, and so forth. So, looking at this, let's say our reference angle is theta. And it's going to be one of the acute angles. So, if A is our reference angle, what we're saying that is this, that this degree measure, whatever it happens to be, will equal the ratio of the opposite side over the hypotenuse. They match up in a table, if you will. They correspond with each other. So that's opposite leg A over C. Using our same reference angle, if we wanted to do cosine, that would be adjacent leg B over C, hypotenuse. And if we needed to find the tangent, then that's going to be opposite, in this case, A over B. Now, why? Well, if I got to know all three of these, we're going to have to know 6, to be honest with you, but you never know what pieces you're going to have. So based on this, the ratio of the opposite side divided by this, that fraction, whatever crazy decimal it is, will match up in the tangent function to a specific angle measure. And we'll talk about that in the future. All right, cosecant. This one's new now. Cosecant is going to be defined as, and see if you can see some relationships here. Hypotenuse over opposite leg. Interesting. Secant will be defined as, and you can see they got the abbreviations in orange, hypotenuse over adjacent leg. And cotangent will be adjacent leg over opposite leg. And I believe some of you intelligent folks have already figured some things out there. I want to go back to this. Better. I'm going to come back to this and just, again, use A as our reference angle. The cosecant of angle A is defined as the hypotenuse, C, over the opposite leg. Again, you should probably see something there. the secant of angle A, hypotenuse, over adjacent leg. And the cotangent of angle A would be the adjacent leg over the opposite leg. So there's our 6 definitions now. You have 6 that you have to make sure you're paying attention to now. All right, so I've labeled theta in this example. I would like us to find all 6. Now you're going to be asked to do these in exact form. So sometimes there are going to be radicals involved. So make sure you're paying attention to that as well. So let's find all 6 of our trig functions. You can find them in any order. I'm kind of a sine, cosine, tangent person, then cosecant, secant, cotangent. So let's do it that way. Simply because I got the pen and I can't hear you guys tell me which one you want. So the sine of theta will equal opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. If you can beat me, go ahead, beat me. Get them written down before I do. The tangent of theta is defined as opposite over adjacent. I'll change colors for our new found trig friends. So the cosecant CSC is defined as hypotenuse over opposite leg. There's theta. Yes, we'll leave them as improper fractions. The secant defined as hypotenuse over adjacent leg. And the cotangent is, like it says there, adjacent leg, so adjacent to theta over opposite leg. There. That's just practicing our ratios so we have them down. Let's see what we can do in this example, shall we? All right, so here's all you have. You're given that the sine of angle B is 5/8. You need to find the remaining 5 trig functions in exact form. We're not taking any decimals and rounding anything. So, let's go. What are we going to do? Well, draw some right triangle, however you want to do it. Sine of angle B. It's one of the acute angles, so it's either going to be here or here. Your call, doesn't matter. So those you chose here, good choice. That's what I'm choosing. So there's my reference angle, or our reference angle. And the sine of angle B is 5/8. So sine is defined as what? Opposite over hypotenuse. So opposite is 5. Hypotenuse is 8. All we got to do is find this third side, and we're in business. So how do we do it? Yes, you're right. Pythagoras-Jones's theorem. So 5 squared plus a squared, 8 squared. So 25. A squared, 64. A squared, yes, I'll wait for you. I can barely hear you. Good call. 39. Excuse me. And when we take the square roots, again, exact form, we're going to have the square root of 39. So label it. I got all my sides. Now start going. We've already done sine. It was given to us, so let's go cosine. B, so the cosine of angle B equals adjacent over hypotenuse. Boom. Tangent. Again, I'm putting angle B. That's my reference angle, so I want to make sure I'm putting these labels in there correctly. Tangent of angle B, defined as opposite over adjacent, starts off. Notice how I said this. As that. Can't have radicals in our denominator, So we are going to change that up and rationalize next perfect square. So as we do so, multiply both top and bottom by the radical 39. There's where our tangent of angle B will be. Now, let's move on. We got our new friends. So we'll start with the cosecant. And cosecant was defined one more time. If I don't know, I go back to my notes. Hypotenuse over opposite leg. So here's hypotenuse. Here's opposite leg. There's my inverse partner or reciprocal partner right there. All right, I'm back to secant now. And if B, sorry. And if we didn't pick up that it's the reciprocal of this. So don't make life too hard, just know my reciprocals. And I will take 8 over the square root of 39. But again, I'll try to keep these in exact format. Rationalizing my denominator, multiplying by the square root of 39. 8 radical 39 over 39. Now, save yourself some work here on this next one. We want the cotangent of angle B, our reference angle. So some people will go with this answer, flip it, that's what the reciprocals are, and then they got to do a bunch more work, or go back to the original, because these two are reciprocals of each other, using the same reference angle. So, radical 39 over 5, go back, adjacent over opposite, boom, you're done. So there's an intro, we're starting to get our recognition of our trig functions.